Okay, so in this section, we're going to start to see a lot of things that say find the global mins and the global maxes of this formula in a certain range. But before we do that, we need to start with how do we even find local mins and maxes of a formula? This is something we kind of could have covered in 4.1, but didn't really need to, so we're going to need to cover it here. So when we're looking for local mins and maxes, the first step is we need to find the critical points. Local mins and maxes always occur at critical points, so we'll start with that. Okay, and so the way we do that, remember, we're looking for where is f prime of x equal to 0, right? And so we'll start by taking the derivative, so f prime of x is equal to 8x to the 7th minus 10, and we want to know where this thing's equal to 0. So we'd have 0 is equal to 8x to the 7th minus 10, so x to the 7th is equal to 10/8, which if you simplify that, you'd get 5/4, and you could use your calculator to take the 7th root to tell you that x is equal to 1.03239. Okay, so this is a potential local min or max of my function. It doesn't actually have to be either, right? My function could look something like, at x equals 1, it could look something like this. That would be a case where 1.03 is a min. It could look something like this. That would be a case where 1.03 is a max. But the problem is it could also look like something like that, where it's neither. All right. So step 2 is going to be decide which one of these things is it. Is it A, B, or C? And there's two ways to actually decide whether it's A, B, or C. The first way is going to be this first derivative test, and this is what we actually talked about in class, is we'll have f prime, we're going to make a number line. And the big idea is on this number line we're going to mark our critical points. In this problem we only have one, and we're going to check whether it's positive or negative on each side of the critical point. And so in this problem, we could come back to f prime and say, well, I'm going to plug in a value less than 1 into my formula here. Let's say I plug in 0. So I would have 8 times 0 to the 7th minus 10, which will be negative 10. So that tells me everything over here is a minus for my f prime. So that means my graph is decreasing up until this 1.03. So it's decreasing up until the 1.03, but the question is, does it increase after 1.03, or does it keep decreasing and do something kind of similar to this, but flipped? So we have it decreasing, so we need to plug in something bigger than 1.03 into the x to the 8x to the 7th minus 10. Let's try to plug in 2. 8 times 2 to the 7th minus 10. Whoa, this is a huge number. It's very positive. 2 to the 7th is big. 8 times 2 to the 7th is even bigger. It's way bigger than 10. Actually, if we do this out, we're going to get 1014, telling you since this thing is positive, everything over here is positive. So what we just found out is, with this first derivative test, is my graph kind of looks something like this. It decreases to 1.3, and then it increases away from 1.3, telling me that 1.03 is a minimum. So negative to positive equals minimum, and that's what happens here. But we could also, if we had the case positive to negative, that would equal a max. That does not happen here. All right. The final way that you could determine whether, we've already determined that this is a min, but alternatively, another way that you can determine if this is a minimum or not is the second derivative test. So what's the second derivative test? So with the second derivative test, I'm going to want to take my second derivative. So I have 8x to the 7th minus 10. So f prime of x is equal to 8x to the 7th minus 10. So f double prime of x will be equal to 56x to the 6th. All right. And so how does the second derivative test work? You plug in critical value or critical point into f prime, and the two options you have are, if it's less than 0, what does that mean? If it's less than 0, what does that mean? Well, it means it's concave down, right? That's what f double prime being less than 0 means. So concave down gives you this shape up here, telling you that your critical value is going to be at a max. And from here you might be able to see, well, that if it's greater than 0, what does that mean about my graph at that point? If my concavity is positive, it means my graph is concave up, which means that I will be looking at a minimum. Right? So draw the graphs over here. Concave up, it's a minimum. Concave down, it's a maximum. And so notice here, if we plug in 1.03, we are going to get, so f double prime of 1.03 dot 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 is in fact greater than 0, which tells me that I would have a minimum. So the whole point of this problem, let's just go over finding local maxes and mins. The big idea is find your critical points. So we're setting f prime equal to 0 and solving, and then decide whether each of those critical points is a maximum or a minimum by using one of these two tests, whichever happens to be more comfortable to you. So either this number line or just plugging in those points into the second derivative.